Okay guys, so here we will see the basic idea of a MapReduce, what does MapReduce, and why we are using this MapReduce, okay, and how it is processing the MapReduce. So we can get all the information from this diagram. So guys, we know that MapReduce is a processing unit, processing engine, and for processing that thing uh, we need data, right? We have to store that. So Hadoop has two main core component. Very first is a HDFS and second one is a MapReduce. By using HDFS, we store the data distributedly. It's a file system, and for processing that data, we need an algorithm, we need a code, bunch of line, custom business logic, which we generally write it in MapReduce, right? So this is an architecture. We have few master. Reason for using few master is that if one master goes down due to any reason, still my standby master will come into the picture. Okay, still my system will be in no working condition. Why we are using several nodes? If one node's down, then still my data is available. So due to which the availability of data will always be there. It won't affect your performance, it won't affect your systems. Okay, and let's see how data is stored, and let's see how data is processed in this MapReduce. Fine, so you will overall get an experience of how it is actually processing it. Let's suppose user which sits outside is only send some files, and the size of that file is in a terabyte. So you have to process, you have to create the meta, you have to create data about data. Okay, that is actually a meta, right? Means you have a file. I already discussed it in our previous slides that you have a data, then you should create a meta. And what exactly meta means? Data about data, like you have created a file has some content, so that is actually a data. Okay, and some additional information which are associated with that data is your meta, like where you are storing that file. First thing, second thing, what is when the file was created, a timestamp, any protocol, any checksum. So these are an additional information about the file. Okay, so that is nothing, that's a meta, that's a data about data. So that information will be stored on master, and actual data will be stored on your node. Okay, so see here the user has submitted the file, and the size of that file is in terabytes, petabyte, anything. Okay, so we have considered the case that let's suppose the size of that file is in the terabyte, and the file has been submitted to master by user. So master will process it. Processing means ultimately it is creating the data for that. It is creating the meta, that is creating the data about data. Now it will store that meta on master and creates certain blocks, b1, b2, b3, b4, and randomly it will be stored inside any of the node. Okay, so let's suppose this node is working. Let me remove. Okay, so b1, b2, b3, b4, these four blocks are created by the framework, and these are stored on node 1, node 5, node 6, and -2 nodes. Okay, so now we have data which are distributedly stored. Now you have to process it, right? Processing means your code, your algorithm. Okay, so the user, what it will do, it will submit your MR job. MR means MapReduce job, means your custom business logic, your algorithm, which actually validate your data, which actually do some operations, right? So it will be submitted to a master. What master will do? Master will create an MR job, and it will distributedly send to nodes, guys. Okay, guys, you know that how master will get this information, that where my data exists. Master has that information. This is the property of data locality, This is the actual data locality operations features. Due to data locality features, MR job will send to the specific node where my block exists. So MR job will be sent to node 1, MR job will be sent to node 5, MR job will be sent to node 6. That's it. Okay, means these are the blocks which are required to process my MR jobs. So master has that information, due to which it will send those MR jobs to this specific node, and after that it will process it, and it will write that output back to HDFS. That guys, let's move ahead to our next slide. So guys, this is a Hadoop design principle. Okay, we know that input file size can be in a petabyte, terabyte, is generally broken into the blocks of size, and it is configurable. Second point, each different data blocks are moved to the different nodes of the cluster. Once storage operation is completed, then user submit their MR job. First operation is the user has to submit the data on HDFS. Second is to submit the job, and fourth point is due to the data locality problem, not a problem, due to data locality feature, master move MR job to specific node wherever this block exists. And last point is when all node process the data, the final output will be returned on HDFS. So let's move ahead.